What's up, Ms. Goldsman? I'm Lane, and this is
Adrian Pena, and today for math we're going to be going over 9.2, 9.3, and 9.4. I hope you enjoy.
starting off with chapter 9.2. Chapter 9.2 is based on angles and radian measurements. The entire chapter involves mostly the unit circle, incorporating angles, radians, fractions, and pi.
This is an amazing example of what a unit circle looks like. Using a unit circle, you can determine a lot. I will have my wingman graph some angles using the unit circle.
In this picture, this is how to plot degrees on a graph with the help of the unit circle. Next, we could also take a close look at degrees to radians and radians to degrees. This photo shows how to convert degrees to radians and radians to degrees. We'll look at a few examples right now. These are the two examples we're going to be going over. These are the finished examples. As you can see, we multiply the left one by pi over 180, equaling 120 pi over 180, and simplifying that gets us 2 pi over 3. And for the other one, we multiply 180 over pi, which gives us negative 180 pi over 12 pi, and that simplifies to negative 15 degrees.
I'm Squidward, and can you help me and go over question 18?
Right now. This is what question 18 looks like. I'll show you how to graph it right now. This is how you solve question 18. First, we multiply 180 over pi, and then that equals 3 times 180 over 4. Then that equals 540 over 4, and simplifying that, we get 135 degrees, and this is what it looks like on the graph. Unit 9.3 involves the 6 trig functions from what we learned a long time ago in Algebra 1. Although in 9.3, we use x squared plus y squared equals r squared to find the 6 trig functions, with y being opposite, r being hypotenuse, and x being adjacent of theta. Let's look at some examples right now.
As a reminder, these are the 6 trig functions.
Here are also some important notes you might want to write down in your notebook. Looking at this problem, I've just written out the most important parts. This is what we're working with right now. As we can see, we have x and y, so we have to find what r is. Using the formula mentioned earlier, we could find what r is using x squared plus y squared equals r squared. After plugging it in and doing the calculations, we get 16 plus 9 equals r squared, which is 25 equals r squared, and squaring that, or using the square root, we get r equals 5.
These are the 3 variables plotted on the graph, and these are the 6 trig functions.
In that first example, it gave us x and y. In this next one, it doesn't, so let's take a look at it. All right, team, due to some technical difficulties, we had to rotate from our prior spot. So, video continuing shortly. All right, team, back at it again. We're rotating out of sight again. Second spot was occupied by some amazing strangers, so we're rotating again, trying for a third spot to get this math video to you. Back to the problems. We found a park bench to work at, so now we already talked about how theta was 270 and x and y is 0 and negative 1. Plugging that in, we can get r equals negative 1 to find x, y, and r, to also find the 6 trig functions. Plugging everything in, we could find the final 6 trig functions. Keep in mind, if the denominator equals 0, the answer is undefined. Another important thing to add to your notes is each quadrant, 1, 2, 3, and 4. As you see in example 4, we moved on, and the tangent is negative 240 degrees. After that, we find x, y, and r, which is negative 1, square root 3, and 2. And using that, we could find the adjacent, opposite over adjacent to find tangent, which is square root 3 over negative 1, giving us negative square root 3.
I'm LeBron, and can you go over question 2, please?
Thank you for asking for help on question 1, LeBron. As we can see, x is 5 and y is negative 12. We'll plug it into the equation and find out what r is. After plugging in the equation, we get 5 squared times negative 12 squared equals r squared. That equals 25 plus 144 equals r squared. And seeing that, adding them together, we get 169 is equal to r squared. Square rooting both of them, we get r equals 13. After finding x, y, and r, we plugged it into the trig functions and we got all of these answers for question 1. I hope this helps, LeBron. After we just finished 9.3, moving on to 9.4. In 9.4, it's about periodic functions. Periodic functions are functions that repeat exactly in regular intervals called cycles. We graph using sine and cosine, and given y equals a, sine b theta, or y equals a, cosine b theta, the amplitude is absolute A, and the period is 2 pi over absolute B. Using all of that, we could plug it in and graph.
These are some stuff you should put on your notes. Here are the example problems for 1 and 2, and we will go over them shortly. In both problems, we find A and B, and with that, we can find the amplitude and the period.
As we can see, the absolute value of 3 is 3, and the period of 2 pi over absolute value of 2 is just pi. And for the next one, the absolute value of 3 over 2 equals 3 over 2, and 2 pi over the absolute value of 1 over 3
I'm
is
Snoop,
equal to
and
6
can
pi.
you help me with number 3 on the back, please?
Thank you for the question, Snoop, and I'll be happy to go over question 3 with you. It's starting to rain, so we gotta rotate back to our original site. Now that we relocated back into a perfect position, I hope you don't mind the rain. As we can see, our A value is 4, and since we don't have a B value, it's 1. Using that, we can find the amplitude, which is the absolute value of 4, which equals 4, and for the period, we have 2 pi over 1, which equals 2 pi. Using that, we could graph it using Desmos graphing calculator. Plugging the equation into Desmos graphing calculator, look at this, which you, Snoop, can graph on question 3 and finish the rest of the problems yourself. Thank you.
And this girl's just a genius. Can't lie, she's a genius. Pull up, let's get high. We on Venus. I just like the way her lips move. You off, keep it. Yes, I have a reason. So disingenuous, it's me heated. You get tricked, so you must get treated. You the type of Bigfoot shit. I'm the type of Bigfoot. Tell me when you want.
These are the finished.
I forgot. I'm very freezing.
Come on.
With.
Dang ya. Thank you for the question. Who said that? Oh, Snoop.
These are the formulas to converting degrees to radius. Nah, I forgot. Oh, I need it right there. Because I forgot. Oh. Alright, see these notes, you can add them. Wait. You can add these notes to your notebook.